Long thin grooves, called gullies, on the surface of Mars may have been made not by water but by blocks of frozen carbon dioxide, dry ice. These blocks seem to have flowed down Martian sand dunes on cushions of carbon dioxide gas. Researchers liken these icy sleds to small hovercraft plowing furrows as they go. The findings, published in the journal Icarus, were discovered on images from NASA's Mars Reconnaissance orbiter. The grooves, or linear gullies, were on Martian sand dunes and varied in length from only a few hundred meters to 2.5 kilometers. They were found on dunes which are covered by frost during the Martian winter. Every winter Mars' southern polar region is blanketed by a layer of dry ice, up to 1 meter deep. In the springtime, this seasonal polar cap sublimes, turns directly from solid into gas. Linear gullies don't look like gullies on Earth or other gullies on Mars, and this process wouldn't happen on Earth, said Serena Diniega, a planetary scientist at NASA's Jet Propulsion Laboratory and lead author of the paper. We don't get blocks of dry ice on Earth unless you go by them. To test whether ice can make such grooves, the scientists obtained a number of such blocks and slid them down sand dunes in the U.S. states of Utah and California. Their tests found that the melting blocks of ice parted sand into small sections as it slid down the dunes. Though this comparison could not account for the temperature and pressure on Mars, the researchers suggest ice blocks could behave in a similar way during the warmer early Martian spring. Snowboarding. A principal clue behind the idea is that the linear gullies end in pits, rather than a fan shape. In debris flows, you have water carrying sediment downhill, and the material eroded from the top is carried to the bottom and deposited as a fan-shaped apron, Dr. Diniega explained. In the linear gullies, you're not transporting material. You're carving out a groove, pushing material to the sides. Dr. Diniega said that she had always dreamed of going to Mars, and now dreams of snowboarding down a Martian sand dune on a block of dry ice. Co-author of the paper, Candace Hansen of the Planetary Science Institute in Tucson, Arizona, U.S., studied the seasonal effects of CO2 on Mars and said that grooves could be unique to those found on Mars. Mars Reconnaissance Orbiter is showing that Mars is a very active planet. Some of the processes we see on Mars are like processes on Earth, but this one is in the category of uniquely Martian. There are a variety of different types of features on Mars that sometimes get lumped together as gullies, but they are formed by different processes, she said. Just because this dry ice hypothesis looks like a good explanation for one type doesn't mean it applies to others.